Well, hello there folks, and welcome to another edition of Random Road Cuts. Here we are at one of many road cuts along this section of the road. This is the Banks-Lowman road, a county road that connects Idaho Highway 55, I believe, with Highway 21 here in the central mountains of Idaho. So we're going to take a look at this road cut here, but just a little bit of context. This road and this county highway lies along the south fork of the Payette River. You might be able to see it way down there at the bottom of this beautiful canyon, a class 4 whitewater section down there known as the canyon section. So we're here on this bit of a hazy morning, but a little breezy and beautiful nonetheless. We've got a little snake skin here off the side of the road, and let's go take a look at this road cut. So thanks first of all for joining me. I'm geology professor Shawn Willsey. Random Road Cuts is a series where we stop, pick a road cut, anything that looks pretty good, roll the camera, and then unravel the road cut together, making observations, trying to identify the rocks as best we can, and then hopefully putting together somewhat of a cohesive story or an interpretation of how the geology came to be here. It always helps a little bit to know the region you're in, but if you don't, that's okay too. I've done plenty of random road cuts just, in Europe or someplace where I'm really not familiar with the geology. Here in Idaho, in this portion of the Central Mountains, there's quite a bit of different rocks that are possible, but the main rock that forms much of the Central Mountains of Idaho in the central part of the state are granitic rocks, intrusive igneous rocks, rocks that form from magma cooling and solidifying slowly underground, and crystallizing to form igneous rocks like granite or granodiorite. So that's one possibility. There are volcanic rocks of the Chalice volcanics and Eocene batch of volcanic rocks, quite a diverse group of rocks actually that are possible. What else? There could be, over as you get to the eastern part of the state, there's packages of sedimentary rocks that are possible. So those are some of the things we might expect, little bits of metamorphic rocks here and there. And let's go ahead and start. We'll start on this end of the outcrop. Looks like a little further down you can see, maybe we'll walk down there first. Big pile of rocks. This section of the highway, rockfall is a big hazard here, and you can see a big section of it down here where the rocks have fallen onto the highway. The highway's pretty beat up and patched up and stuff, so little longer view there down the road cut. But let's start over here, and I think the most arresting thing, the reason I chose this one, was it had some diversity. We've got these light colored white, light gray rocks, but then these dark, nearly black, at least dark gray features that are cutting through the rocks. So we'll start with this and make some observations here, see what we can see. So here's a good look at the light colored rocks. Speckled, I can see visible crystals in the rocks here, but they're big enough to see with the naked eye. So we have little dark specks here, a little bit shiny even though the sunlight's not out. Those look like biotite. The larger areas here of this kind of smoky gray color, these are quartz. And then a lot of the white, and there's a little bit of pink in here too, those are our feldspar minerals. So with this assemblage of minerals and this texture, this would be a granite or something close to a granite, these light colored rocks here. So we've got granite here, and then if we look back up at the outcrop, we can see this very sharp and striking contact between these dark colored rocks, which we still need to identify and figure out, and these light colored rocks. And just here's a good look at the contact here. So these dark colored rocks also show crystals as well, but they're a little bit more fine-grained, kind kind of a grungy looking rock. It doesn't kind of pop with the crystals as easily as this light colored one here. But it looks like it's probably either a basalt or maybe a very dark andesite. So two other igneous rock types. And so once the rocks are identified, then we might want to figure out the relationship between the dark colored rocks and the lighter ones. And so we can use a basic principle in geology here to help us out, one that turns out to be quite useful, and that's called the principle of cross-cutting relationships. So it basically states that any rock or feature that cuts existing rocks has to be older. So in this case, we've got the light colored rock, the dark colored rock, but the dark colored rock is cutting through the light colored rock, which tells us that the lighter rock, the granite, was here first, and that this basalt or andesite, the dark colored rock, occurred later. Now this all being igneous, these would be dikes. So this is a dike of magma. So basically magma was injected through this rock once it had cooled and solidified. So a fracture moving, or a magma moving through a fracture in this lighter colored rock, filled that fracture with this mafic magma that then cooled and crystallized to form the actual dike that we see there. Let me back up a little bit here, and we can actually see the dike continue up past this block and up to towards the top of the outcrop. So you can see it actually cutting through the entire extent of the outcrop there. So two different rock types and two different distinct geologic events that formed that. And so that's part of our story here at the Roadcut. As we scan across, it looks like it's most of the same granitic material, but you can see there's some fracturing to it. A lot of times this granitic material will weather into, it'll disaggregate into a material called grus, G-R-U-S. Let me see if I can find a little pile of that to show you a little bit more closely. So that's just a fun name for, this broken up, weathered, disaggregated granite is grus. And then of course it becomes sediment, which can then become incorporated into rivers and streams and such. There's a little bit of a seam right here. You can see it kind of pinched down at the bottom, which may be another dike, but also could be something else. Let's see if we can get up there. So here's this lighter colored material. And doesn't look as igneous as the mafic dike we saw elsewhere, but it is cutting through the rock. We can see it going up the cliff face here. So we can still use the principle of cross-cutting relationships, but what this may be, rather than magma that was injected into the rock, this could be fluid. So if a fracture was filled with fluid that then cooled and crystallized, you would get what's called a vein. So rather than a dike, which is igneous magma, this could be a vein of some mineral. Can't quite tell exactly what it is, but it's not quartz or some of the more obvious mineral veins that I can think of. Let's head down a little bit further, just kind of scan the outcrop. More of the same here, and then we get to another big stripe cutting through the rock, and because we've already seen one of these, we probably feel like we have a good feel for what this may be. And yeah, this looks like the first one. I can see this one a little more clearly, some of the crystals in it. So this is another basaltic, probably basalt, maybe basaltic andesite dike cutting through the rock layers here. Now a lot of times when we get dikes like this cutting through existing rocks, because this is magma, which is hot and is moving through fractures in the existing rocks, is sometimes along the margin here, along this contact, you'll see some discoloration, maybe some different mineralization. It'll look different. And some of you may be familiar with the term contact metamorphism, meaning that when one rock type is in contact with magma, the heat and the chemical changes that take place along that contact will cause some metamorphism or some changes to take place in the existing rock. And we don't see that at all here with the granite. And that should make sense, because remember, this granite formed at very high temperatures as well. This was itself once magma that cooled and crystallized. So when later you have another batch of magma, albeit a slightly different chemical makeup, injected into the granite, the heat doesn't really cause any appreciable changes to the rock there. So there's really not much of a change between the dike and the granite here in terms of any sort of metamorphic change there. It's a bit of a step over here in the dike, so almost like a little bit of a transition there. And then there's some interesting fracture patterns up here in the dike. Just the way some of those faces line up is kind of interesting. As we step over just a little bit further, looks like there is a second dike, a little bit thinner one, that comes down and intersects right here. So this one's just, you know, almost a hand's width or so. Holy cow, this is hard walking through here. Yeah, very narrow little zone here where this secondary dike cuts through the rocks. So we got another one there, and then let's just keep cruising down the outcrop here. The footing's a little tricky here, so apologize for the inconsistent camera work. Let's see, is it here? Let's step down here. Okay. Yeah, so more of this fractured granitic rock, and then it looks like we hit a couple more dikes. But let's just double check. Yep, so there's one here, just one side of the bush, and looks to be the same material, so most likely the same batch of magma from the same event, just sometime after the granitic rock formed. And then this is interesting here. I need to back up here to get the whole picture. I need to back up onto the road, actually. Here we go. So check this out. So we've got a dike right here down just below the bush, but then it changes direction, comes up through here, and then resumes cutting up through the rest of the rock up this way. So you get some interesting geometries sometimes in these dikes. Remember, they're just taking advantage of whatever pre-existing weaknesses lie within the rock, whatever fractures exist that they can exploit as that magma is injected into the rock. Another one right here, cutting up. This one's interesting because it kind of thins out a little bit, but then there's another one that takes off over here. So it's pretty interesting. Again, same material for the most part. And then coming down, looks like there's another very large one here, almost a meter in width, that cuts through the rocks. A little bit of some green mineralization on the face here. Probably epidote would be my guess as to what that is. I don't think that's necessarily related to the dike. Could be more weathering related than anything. So a couple of interesting dikes cutting through the rocks here, and then kind of wrapping up as we move our way down, another small dike right here cutting through the rocks. And there's a bit of a weathered little trough in the rock. Looks like it's mostly granite coming through, but then the left side, a little darker there, looks like another dike. And more of the same material here. Car coming, so I need to step in a little bit. Road will get a little busier as the day goes on. Yeah, same material here, just double checking. You can see some of the muscovite or biotite in there. Just highly fractured, this granitic material. We have a couple different ages and types of granite in this portion of Idaho. Here's something a little different. So now we have a contact along the bottom, but even from back here I can see it's quite a bit different texture, this dark material. So rather than the fine-grained basalt we saw earlier, we've got a nice contact here between the granite and this new dark material that has these big plagioclase feldspar crystals. So this is much more of a, with these big crystals here embedded in this more fine-grained matrix here where the dark gray is, this looks a lot more like a porphyritic rock. So a different texture than what we've seen in other places. You can see how big some of these crystals are here. In fact, I'm gonna bring you over to this little spot where you can just really see this beautiful texture here. So there's black crystals, large crystals of amphibole or hornblende, and then these large white, oftentimes rectangular crystals of plagioclase. So this looks to me like a true andesite here. This is a very classic andesite. Again, I think we have another dike here. This one's coming up at a very different angle. We saw the other dikes were near vertical. This one's cutting across much more obliquely across the granite. So possibly a different dike here. Could be different age, could be the same though. You can see that perfect contact over to this point. Then it looks like it becomes a little steeper, a little hard to access up there because it's quite high in the outcrop. And this andesite dike occupies a much wider zone. That's all what we're seeing right here. And we can see again those big crystals, this porphyritic texture in the andesite dike as it comes across. And let's see how far it goes. Yeah, and then here's the bottom contact, the other end of the dike right here. So that's a good, in terms of width, back up a little bit, that's probably a good, yeah, like 5-6 meters, maybe approaching 20 feet in terms of the width of this thing from over here on this side over to this point here. Those are the two contact points for this large dike. So anyway, that's pretty much the end of the road cut, and a little bit of a long-winded one at that, but I wanted to take my time and work my way through it. And then as we come down beyond the end of the road cut, you can see some more highway engineering solutions to the rockfall problem. There's a bit of netting here down at the end of this gully where the rockfall's been occurring, where they're trying to catch these rocks before they fall out onto the road. Then you can see how the road's just been patched up quite a bit here and there. So anyway, pretty good stuff, team. Hope you enjoyed that fun little edition of Random Road Cuts here in the central mountains of Idaho, one of the more beautiful places in the West. Great geology, great scenery, and we'll take you on one last little look here down into the canyon with the South Fork of the Payette River somewhere down there. See if we can get to a nice little point here. I can hear it. Yeah, there's a little look at it down there. Hopefully you can see that. There we go. yeah, and just a beautiful section of landscape here. Hope you enjoyed this edition of Random Road Cuts. Thanks again for your support of the channel, and we'll see you at the next road cut.